Recently, I was on a conference call with clients, and one of them said, "Ed, why don't you explain it better? Why don't you give credit where credit is due?" Let's take a look. Picture bottom right. The blue oval is the amount seen and standardized by IEC 61300 3.35. All video inspection, including auto detect, only sees this relatively small surface area. There is also a zone 4. That's the way I characterize the total horizontal surface. The blue area is characterized zone A, B, C, and D. There's also a zone 5. The zone 5 completes the total three-dimensional perspective. As well, adapters and alignment sleeves are zone 5. No standard addresses the connection, the adapter, the alignment sleeve. When I started learning about fiber optics, and it's one of those topics, the more you learn, the less you know, but when I started learning, I focused on cleaning. There were two standard methods in 98, 99, 2000. There was dry cleaning, and there was wet cleaning. NTT introduced the classic Clee Top reel cleaner, still used to this day, a marvelously convenient piece of equipment. The other way to clean was wet cleaning, and that was where the amount of solvent was undefined. Perhaps an isopropyl alcohol wiper. Perhaps some of you are still doing that to this day. Where did it come from? Where did wet to dry cleaning come from? Wet to dry is half an instruction. In the mid-2000s, I was awarded 2 patents, and those patents define wet to dry cleaning, but they don't do it the way that you've been taught to do it. Wet to dry cleaning includes a drying process, and that's what this video will show you. Here's a fingerprint, and this is a cleaning technique that over the years I've seen, and I've asked technicians, how do you clean it? And what they'll do is draw the end face through an isopropyl alcohol wiper. Maybe do a figure 8. So this is of course wet. You can see this there, and it'll begin to evaporate and flash off. So of course the wet to dry process is to take a wiper, swab, something, cleaning platform, probe tool, and then dry it. But sometimes the action of putting the end face into that wiper isn't as effective. So now let's take a look. Well, now you see what's happening. This solvent is flooding from zone 5. So now in most video inspection, you're going to see this. Now we should be clean and dry. So this is going to pass all automatic inspection, but outside of the field of view, something you can't see. The half instruction, what's missing is the amount of fiber optic solvent to be used. As you see, excess solvent, either from a pad or maybe it's sprayed, can flood from the zone 5 area. Since most inspection and certainly most training and standards don't discuss zone 5, this is a problem. The other problem is the type of solvent you're using. If the solvent evaporates too quickly, if it's not strong enough to to remove the debris, the result can be a residual contamination, and that residual can be more difficult than you were initially trying to remove. In 2014, I published a study that talked about different ways to clean, different methods and procedures. These awarenesses are very important. So let's resolve this topic once and for all. Wet to dry is a half instruction. The 2014 comparison book, it's available on Amazon, was really an amazing revelation. Actually, not for me. But what it did prove is that all of these tools worked far better when they were lightly moistened. The result was 90-95% first-time cleaning of some very difficult soils. So this vendor-neutral approach to precision cleaning is adaptable to the tools you're using now. The important thing is to retrain what may be the last 15 or 20 years of mistraining. I've coined the term solvent transfer for the procedure that I clean and the one that I study. Dry cleaning doesn't work. It creates a static field. It moves debris. It doesn't remove it. Wet to dry cleaning, the undefined wet to dry cleaning that is not being properly trained, can flood the connection. So solvent transfer, lightly moistening every tool, is really best practice.